Hello, my name is Yusha Bey. I'm one of the engineering cleanroom staff here at the CNM2, and I'm here to walk through the operation of the EVG 620 mask aligner. Okay, so when you first approach the tool, one of the things you need to check before anything else is make sure that the lamp controller has the lamp on. So we find the lamp controller underneath the tool. Okay, so down here we have and the two values that we're looking for are our lamp temperature and our lamp power. We have a 350 watt bulb, a high pressure mercury bulb for this tool. So you want to make sure that that always reads 350. Also, we want to make sure that our lamp temperature is between 160 and 180 Celsius. From time to time, this will just randomly shut off. So, and that'll be indicated by the fact that that'll be a room temperature, like 22, 23 C, and that'll be at 0. In that event, please contact the CNM2 staff, and we'll help get this back online. Once you successfully see that that is on, next thing you want to do is actually log on to the tool. So you have your badger log on just to enable the tool. Then you need your second log on, which I'll provide you during a face-to-face training in order to actually get into the software application to operate the mask aligner. We'll see that our keyboard here is buried under here. So we have this little door here. Then the keyboard itself is held in place by these two little metal clips. Just need to push them inward and the keyboard slides out. Right here is our mouse. We can move our arrow around. So we want to go to the login little box here. Then we're going to go ahead and type in our username. I'm just going to type in mine. Alright, so I'm logged into the software application. I want to put away the keyboard, close the door. So first thing I want to do is open a recipe. Right here you see you have several options here, new recipe, open recipe, save all recipes, etc. So let's go to open recipe. And so it's good that this popped up. So I have, junior engineers that come in here and run uniformity and make sure that the lamp is providing the right intensity, and also to do a software backup once a week. So every time they turn off the computer, it'll open up to this EV6XX folder. So if you do come across this, you'll find that your recipes are found in the recipe folder. Then here you'll see that we have group folders and individual folders. It's going to go to my folder. And I'm just going to open up a standard recipe that we use in the clean room. Okay, so we use, and by the way, we use a Microchem S1813 photoresist, 1500 RPMs, and 30 seconds, and that'll give us roughly 2.1 to 2.3 microns, and then we end up needing an exposure dose of 54 millijoules per centimeter squared. Also, you have a soft bake, 110 Celsius for 3 minutes. So moving back to the recipe, so you see you're in this little general box here. So we have process mode, exposure mode, and contact mode. So we go to a little drop down menu here. You see you have a Nodig bond, bottom side, first print, and top side. So this is an opportunity for me to also let you know that not only can this tool do top side alignment, it can do backside alignment. It can also align two wafers. We have a companion tool to this. It's also a standalone tool. It's a wafer bonder that can be used. So we have our bond chuck that would interface with the aligner. We align our two wafers, and the bond chuck will hold these two wafers in place. Then we'll take it to our bonder, and then we can do a bond and get within a couple microns registration accuracy. So in any event, most cases you're either doing top side or first print. So we just do top side. That's what like 99% of the users do. When you're doing top side, your process mode to be transparent. However, I guess going back to the process mode, if I go to say a backside alignment, you see you have other options, crosshair and overlay. So crosshair meaning that on the screen you have the opportunity to move a digital crosshair around where your alignment marks are, and then once you proceed in the process and you activate the backside objectives, you'll be aligning the marks, your alignment marks on the backside of your wafer to a digital crosshair on the screen. Then you have an overlay option where you'll just take a snapshot of those alignment marks on the top side, and then you're just aligning your backside alignment marks to a snapshot of the alignment mark. So it's kind of a personal preference. I know when the service engineer was here, she preferred the little crosshair, the digital crosshair. So we'll go back to top side. It's a little side note there. Top side, you only have one option, transparent. Then here are your exposure modes. So you see constant dose, dose interval, constant time interval. So this is one, I guess there's a few differences between this and our Carl Seuss MA4. This one for the exposure mode, you have the option of doing just a dose or doing a time. When you specify a dose, the tool will automatically perform the integration for you. So based on the intensity, as long as the bulb is maintained, as long as we keep monitoring it and we keep it above like 13 or 14 milliwatts per centimeter squared, you'll always get your specified dose. However, I have seen in the past when I've was a little late changing the bulb and the intensity dropped to like 12 or 11 milliwatts per centimeter squared, the tool doesn't have any type of feedback mechanism to say, hey, it's time to change it. It'll just expose it, and you're thinking you're getting, say, 54 millijoules, but in reality you're getting something less, and then you'll just find out when your product doesn't really develop well. So yeah, as long as this bulb is changed every like 4 to 5 months, constant dose works perfectly. Unlike time, so with time you need to know. So if I went to like a constant time, which is probably what most of the users are familiar with using other tools like the MA for the Carl Seuss or other contact aligners, if you put in constant time, you need to know precisely what your lamp intensity is, and so you can do that manual adjustment. So that's when I train users to always use constant dose, because it's like, hey, less effort, you don't got to think about anything. The tool does work for you. And finally for this section, you have your contact modes. You have your hard contact, proximity, soft contact, VH contact, and vacuum contact. So let me walk through these 5. Hard contact is when the chuck has a pneumatic, like a nitrogen pressure that pushes the chuck towards the wafer. Proximity is how it sounds. It's like you'll literally have a gap of whatever proximity you want, 10, 20 microns, so you'll have no contact with the mask. Soft contact is a mechanical pressure, so that chuck is mechanically pushing against your wafer. VH, so it's like a vacuum and a hard contact, so you have a vacuum contact and the combination of the hard contact. Then finally, vacuum contact. So this is the most intimate of all the contact modes. It's really that little area on the chuck where your wafer is residing. It's like a little vacuum is created in there, and that is what creates the pressure against the mask. And that can get you down to a resolution, if you're careful, of course, and with some process development, down to 500 nanometers, according to the manual, according to the vendor. Most people use the vacuum contact. And on average, people will get like a resolution of 2 to 3 micron, easily with this instrument. 1 micron with some effort, half micron with a lot of effort. Okay, so once your general parameters are dialed in, now we're going to go ahead and specify our mask holder in our chuck. To do that, you click on the image of the mask holder. In here, it shows you, hey, you have a 7-inch, so here's another opportunity to talk about another feature. We can do 4-inch and 6-inch wafers. Also, users will do pieces. I guess on all mask aligners, people do pieces. However, you have to trick the chuck into believing that you have a 4-inch wafer, and people create a little adapter out of like a piece of dicing tape or silicon rubber. Well, they'll just puncture a hole where they want their die and cover up all the other vacuum holes with that silicon rubber. Going back to the mask holder, so yeah, if I have a 6-inch wafer, you need a 7-inch mask holder. If I have a 4-inch wafer, you have a 5-inch mask holder. You got this little activate column. So here you see a little cartoon changes to something that's approximately 7-inch mask holder. And that's what a 5-inch mask holder will look like. And once you check the row you want, you go to OK. It's locked in. Same thing with the chuck. We go to the image and see 6-inch chuck, 4-inch chuck. So we can just toggle between the two. So yeah, we want our 4-inch chuck for this example. We press OK. Now that's dialed in. Going to our next set of options, so you have another general set of options in regards to your separation when you are aligning your wafer, your mask thickness, your substrate thickness, and your resist thickness. So yeah, separation when you're aligning your wafer, your mask thickness. So these last three parameters are nice for when you're using the autofocus. So this tool does have an autofocus feature. So if you're processing the same wafer, same process over and over, the tool will automatically bring that surface into focus. For this example, so yeah, typical mask thickness will be 2.3 millimeters. Substrate thickness is 500 micron, 0.5 millimeter. And our resist, 1813 spun at 1500 RPM, about 2.1 micron. So exposure. So let's go down here. So that's self-explanatory. So we're doing 54 millijoules per centimeter squared. Of course, that's process dependent, photoresist dependent, substrate dependent. And then there's another set of options here, and this will be the final section, contact force. So most people just use the factory standards here. I've never had to really play with these. However, it's all process dependent and depends on how advanced that user is. They may find that it's important to adjust these values. Okay, so once all this is dialed in, we can go ahead and press this big old run button. It always asks you to save your changes, and it will not let you proceed unless you save. Okay, so here is an opportunity to change the optics for our top side objectives. And really, you only have one chance to tell the tool. This is your only opportunity at the beginning of this recipe to tell the tool what set of objectives are you using. To change objectives in the software, you just click on the image. Goes to 5x, goes to 20x. So I'm going back to 10x. And also, if you ever need objectives to be changed, please contact the staff, and we can adjust those for you, or provide you with a 5x or 20x if you need them. Going forward, so in this bottom left corner, we got to press continue in order to move to the next step of our recipe. Okay, so this is nice because it's like kind of like a built-in manual here. It says move out tray. It has a little animation of the tray moving out. So our tray is this right here. We call that the tray. So we swing that out. So I swung it out. However, you see that it still says move tray. Now, it's not telling me the next set of instructions. and that's because there is a little interlock here, little switch that needs to be activated. So you have to pull this a little bit further back. And also you see that this now locks in place. If I try to move this tray, it just snaps on back. So you can only move the tray when the software has that move tray sentence up there. Okay, so now the instructions are to insert mask holder, then press continue. So this is like a real life example here. Like 9 times out of 10, your tooling will be already installed in here. And if I was just running a process and not creating a training video, it'd be a continue, continue, continue. However, I'm training, so let me show you what it looks like to take out the mask holder and put it back in. And I'll also show you where our tooling is stored when it's not in use. So I'm going to place the mic down for a second. Well, first step is to undo these screws. Do that. Okay, screws are out. So, I see a lot of people will try to just kind of rip this mask holder like directly up. However, that's not the best way to do it. The best way to take this mask holder out is actually like use your left hand or your right hand, grab like this edge that's closest to you, and you want to pull it towards you. There's like some like ball bearings, some springs here. You pull towards you. So while you're pulling that side towards you, you want to grab the top side and you want to rotate it out. So this section is kind of like a hinge. Let me show you what that looks like. Yeah, all too easy. Comes out nice and smooth. So when you're looking at the mask holder, if you ever have to change mask holders, there's a few little O-rings you want to look for. Although this hasn't happened recently. You want to make sure these little O-rings stay in place. One O-ring is right here. And then you have 4 more. So I can bring the camera a little closer. You have 4 O-rings inside. 1, 2, 3, 4. Make sure those are there. Those help with vacuum to your mask. So if those aren't there, if you're having vacuum issues, of course, please contact the CNM2 staff. The camera comes a little closer. So we store our tooling for the EVG in this little rack here. You see that we'll store like our chuck and our loading frame together. Oops. That's our 7-inch mask holder. So everything stays here. Okay, so now we are going to insert the mask holder. So to do that, it's kind of like, not kind of, definitely the reverse order here. So when I put this in there, I want to, this edge that's closest to me, I'm going to pull it towards me, and then I'm just going to rotate it down in. Let me show you what that looks like. That should go in very smoothly. Shouldn't be any friction. It should be no difficulty at all. And then you may have to like kind of push things down, make sure they're in. That's all good. So now it's coming back to the software. We're going to press continue. Now, yeah, literally showing every step here. So now we want to put these screws back in to fix the mask holder in place. Let me show you what that looks like. So we definitely do not want to crank down on this. There's no reason. One concern may be that, oh, how do I know this is flat? I'll show you a feature in the software where we can store our spatial points. We can store our X, Y, and Z coordinates of our objectives. So say like you're scanning across a 6-inch wafer and there is a height variation. Because you can store those points, you can always be in focus. Like you're just like a click of a key, click of a button, the microscope will automatically come into focus. Okay, so now we fixed the mask holder. We'll go to continue. Alright, so it wants us to insert chuck, connect vacuum. So I'm going to go ahead and take the chuck off first and the loading frame. So this is our chuck. Looks expensive. It definitely is expensive. Okay, so when we're aligning this to the tray, we have a hole right here. And also more obviously, we have our vacuum fitting right here. So this is our correct orientation, vacuum fitting next to that tube. And that hole will line up to this little white post here. And this thing just kind of just floats like so. Then we'll connect our tube to our fitting. Sometimes when you're putting this tube on here, it may be sticking up like that. You definitely don't want it to look like that. So always make sure everything is focused and pointing downwards. All right, so chuck is installed, vacuum connected. We go ahead and press continue. Insert our load frame. So the load frame is used to actually load our mask to the mask holder. The mask is held purely by vacuum. There's no mechanical clamp, unlike the Carl Zeiss MA4. So it's all vacuum. And also you'll see a nice feature here. We have an opportunity to align our mask to the optics of the tool. So anyways, back to the load frame. These posts line up to these holes on the chuck. All too easy. So that's installed. Press continue. Now, getting close to the main event, we're going to put our mask onto the loading frame. You need 2 hands for this. I know several types of experience. I know our users have all types of experience. Some novice, some super advanced. I'll just go through this step because it'll be recorded forever. Yeah, your mask, you have one chrome side and you have a glass side. So we always want the chrome side facing down. So how do you know which side is the chrome? Probably on the camera, very difficult to capture, so I won't say it, but the one thing that's kind of common among everything is that when you're specifying your mask, you'll most likely specify to say right reading chrome down. What does that mean? When you have text on your mask, if you can read your text from left to right, that means the chrome is on that opposite side pointing down. So I guess we'll get the camera in here after I put that on there. You'll see that you can read the text PMOS mask. Yep. Okay, mask inserted. We'll go to continue. All right, move in tray. And again, just a reminder, I have to follow these steps. If I tried to move that tray before pressing continue, it would have just whipped right back because it's a break in there. Okay, now we need to center the stage. I guess it's kind of like the home position. So when we're loading the mask and unloading the mask, we want our verniers to be at a home position. So home for these micrometers. So we're going to bring the camera in here. So EVG has defined the home position to be the 5. We have these engravings on our micrometer. So we'll go ahead, bring that to 0. Like so. And we'll just check the other ones. I mean, 9 times out of 10, they're always zeroed because that's where it have to be to unload the mask. So we'll continue. All right. Now we see we're doing a wedge error compensation for the mask. So this is the planarization step. Make sure that everything is as flat as it possibly can be. Okay. Bringing everything into focus here. Okay, so now, so it says adjust microscope. So yeah, it's an opportunity. This step really, truly is an opportunity to get our mask to be squared up to the optics of the tool, which is so nice when it comes to aligning. So now I'm going to introduce you to some, I guess we're going to go into some alignment steps or alignment processes that are necessary. So here, first thing I want to show you is how to select your objectives. So you have your left objective, your right objectives. When it's green, you're on that one. And here's our joystick. So you can move left and right. So what you'll see is that independently the microscopes can move left and right. However, if you're moving back and forth, that moves this whole head at the same time. To focus, you actually turn the joystick. So you want to hold it. Yep, now we're in focus. And also this gives you some positional data right here for your objectives. And let me go ahead and bring the right side into focus. There we go. Okay. So now for my mask, I have 4 layers on one plate. I guess each quadrant has a layer. So I'm going to go ahead and move my objectives to the first layer. Show you what that looks like. So yeah, this is my layer 1 set of alignment marks here. And since we're here, I can subject you to how I align my 4-inch wafers. Okay. I'll go ahead, I'm going to bring the left objective on over. Bring it over to layer 1. There we go. We have our left and right. So wow, it's our lucky day. It's already pretty in line. So I just need to do a slight tweak. Let me go back here. So I want these two lines to be coinciding. So to do that, so when you're aligning the mask to the objectives, all you can use is your theta. So I should mention that. Your theta micrometer, this micrometer moves your wafer back and forth. This micrometer moves your wafer left and right. So for mask alignment to objectives, you can only use your theta. Boom. Okay. Now they're aligned. So now I'll go ahead and press continue. All right. Remove the load frame. Press continue. Now once the wafer. Have a little dummy wafer from our integrated circuit class taught here at UC Davis. So I want to align my flat to these two banking posts at the bottom. So now when I press continue, that's when the vacuum will be activated for that chuck. And now I can move in my chuck or move in the tray. Doing our wedge error compensation, making sure the wafer is parallel to the mask. Doing our autofocus should bring us pretty close. There we go. So first let me bring these into focus. The right side's pretty good. So go to the left. Very good. Alright, so let me show you some other features before I go ahead and align this. So you see you have some more additional options for the display here. You just choose the left if you just want to view your left objective. So that'll take up the whole screen. I guess these come in handy when you're using pieces because you can only really use one objective if you have a 10 by 10 millimeter die. Same here, I can just purely look at the right side. If I want to expand this, you have the option here. I have like the two arrows pressing out, so it takes up the whole screen. Then here is our split screen. And I can do the same thing. I can take up the whole screen here. Then we have our digital zoom right here. So I can just go double 4 times. Quite pixelated, so you know most people actually put in a 20x to get a better quality image. Okay, those are the main features. So another nice feature, well here let me show you the recipe. So here important to note that you're not locked into those parameters that you defined earlier on when you're setting up your recipe. You can see that any time you can change your contact mode. Okay, anytime you can change the dose, you can change your separation. Little story about this, not really a story, but I found this useful when I'm using thick photoresist or I have like a thick edge bead that sometimes it'll stick to the wafer when it's doing the wedge error compensation. So if I set that to like 200 and then bring it back up, I can align. In fact, let me show you how to do this. It's not really intuitive. So say I want to change my separation between my wafer and my mask. I can do that here. Say I want 100. You'd press set. And then you had to go down to this green move to button. for it to actually happen. Now we're at 100 micron. So I want to go back to 30. And like I said, this is particularly useful when you have a thick resist or a thick edge bead. That really comes in handy there. So those are your main things. And then you can see you can also adjust your contact force, your exposure force. Oh, also some other things here. I guess going back to our display, from time to time, you may have no image that appears. Sometimes you may need to activate the LED. So you come over here and just kind of like move the little switch scroll bar around, and that'll wake up the LED. Also, you see you have like brightness options, contrast options. Okay. Another little handy thing is the ability to store and load positioning. So yeah, if you have a die, like in particular, if you have like if you're using one objective, like right now I have 2 objectives, so I wouldn't really use this feature. But if I'm working on a die where I only have one objective, but I still need to scan across that die to see both alignment marks, this is really, really, really helpful. So, save position. You have the save position button here. And so these are all the previous stored points. So you can just go ahead and pick the first row. And you press save. And so you'll see that these XL, YL, that all corresponds to these values right here. So now, let's go ahead. Let's go and just randomly move. It's right here. I'll go to row 2. And I save. All right. So now to leave this menu, to leave this, you have to go back to save position, press the green button. So now to load those, you go to load position. So I want to go back to my previous point, so row 1, then you press move 2. Boom, and immediately it just jumps back, and it's pretty quick too. So now if I'm working with a die, I don't have to manually fiddle around with the joystick and adjust the focus. I can just store those points and it just will toggle back and forth. It's a very, very beautiful thing. Okay, so I want to leave that. Okay, so now I'm going to go ahead and perform the alignment. So for my alignment mark, so I'm aligning my... Well, let me do one thing. Kind of want to reduce. There you go. I like this view. So this wafer already has all 4 layers patterned. It's a fully patterned wafer. So pretty much I just need to find my alignment little bar there. Just get it in there. So let me show you what that looks like. So first thing I want to do is just kind of just move it around. So I see, okay, there's that alignment little area. Oh, there it is on the other side. So we see that I have a lot of theta correction I need, because I pretty much want 1 on this side, I want 1 on that side. So I'll just go ahead and do theta. I'm just going to go ahead and move this back and forth, see where we are. Oh no, that's too far. Oh, there we go. So there's a 4. 4 on the left side, 4 on the right side. I'm going to use more theta. So you may also be noticing that my right objective, so the right side is moving while the left side stays stationary. And that's because theta is most sensitive near the edge of the wafer, so our right objective is near the perimeter of the wafer. And so I wouldn't expect much movement when I use the theta micrometer from the center. Now I'll use my back and forth. Now we see they're pretty much aligned. So I just need to make sure that this little aluminum line kind of fills up this open gap here. Go ahead and get the corner of the right side. And they're aligned. For all intents and purposes, of course, I would go a little further, but right there, that was an alignment sequence. Hopefully I wasn't in the way too much. But yeah, that's kind of the combination of using the microscope, using the micrometers to get it done. So once you're satisfied with your alignment, you press continue. And that will take us to exposure. Pretty quick. UV path is shielded, so, and also we're safe because as long as you have your safety goggles on, which is made of I believe a polypropylene, that blocks, and don't quote me on that, but this material absorbs UV radiation. So we're done. Successfully completed an exposure. Okay. So then we press continue. So now we have the option, if we press continue, to do more processing, more wafers with this mask. But we don't want to do that. We want to exit. Exit will allow us to take our mask off the mask holder. So let's go to exit. So loading the load frame, same way as we did before. Press continue. Rotate that tray in. Make sure these micrometers are at home, which is the 5. I did do some significant movement, especially of theta. Micrometers are homed. Continue. Mask unloaded. We're done. So let me put our mask away. Okay, so we will never ever leave the tray out like this because considerable damage may result. We always want to park the tray. Let me show you how to do that. So we need to exit out completely. Go to System. Go over to Park Tray. Press Continue. Move the tray in. Boom. Then this is the idle position. And yeah, please, it's okay to leave the tooling here. That's completely fine. And but yeah, we always want to make sure that this tray is parked. Keep our equipment safe. Then you just log out. And that's it. Yep. Thank you. Thank you for watching.